In this video, we'll cover a couple of different ways to synthesize carboxylic acids, and we've actually already talked about one method to synthesize a carboxylic acid, but we could do this with a couple of different starting materials. So the first was showing the oxidation of a primary alcohol. So if we have something like propanol, in the presence of one of those chromate oxidizing agents, here's potassium chromate. And then in some version of acidic water, so that could be sulfuric acid, aqueous, hydrochloric acid, that's aqueous, any of those. And so this reaction forms a carboxylic acid. We're now at that terminal carbon. We have our carboxylic acid group. And you might remember in this mechanism, or I guess in this reaction scheme, we didn't draw out the mechanism, but in the reaction scheme, the primary alcohol is first oxidized to an aldehyde, and then the aldehyde is further oxidized to a carboxylic acid. And so similarly, if you're starting with an aldehyde, so let's say we have propanol, and add one of those chromate reagents, again with the presence of an acid in water, then this reaction would also produce the carboxylic acid. So we have oxidation of primary alcohols and oxidation of aldehydes. So provided that you have an alcohol or aldehyde starting material, you can add an oxidizing agent, one of the chromate reagents, not PCC because that one ends at the aldehyde, but the other ones that we discussed, and those would produce the carboxylic acid product. Now, another way to synthesize carboxylic acids is through using Grignard reagents. When Grignard reagents are in the presence of carbon dioxide, they'll react to form a carboxylic acid. So we'll show that mechanism here. So we have a propane chain, for example, bonded to magnesium bromide, and then carbon dioxide. So carbon double bonded to two oxygen atoms. And now we've talked about how a carbonyl carbon is lacking electron density, so it is electrophilic. It wants electrons, it can accept electrons, and that's what we've shown in many mechanisms with aldehydes and ketones. Well, in this carbon dioxide molecule, this carbon is bonded to two oxygens, and both of those oxygens are pulling electron density away from that carbon. So that carbon in carbon dioxide is also susceptible to nucleophilic addition. So now if we have a Grignard reagents in the presence of carbon dioxide, the carbon that's bonded to magnesium in the Grignard reagent owns more of the electrons in that bond, or has a stronger ownership of those electrons in the bond than magnesium does. And now I'm talking about this bond right here. And so that carbon with the electrons in that bond can then create a new bond to our electrophilic carbon in carbon dioxide. And then one of the pi bonds will break. You could show it at either oxygen. It doesn't matter. They're equivalent oxygens here. So then this produces a product where that carbon bonded to magnesium is now bonded to carbon dioxide carbon. That carbon dioxide carbon has one double bond remaining to an oxygen, and then now a single bond to that oxygen that gained electrons in the pi bond. So let's trace some atoms and electrons here. The electrons in the bond that I highlighted in green from the organometallic reagent are now the electrons in this bond between the two carbons. So that's that new carbon to carbon bond. The oxygen that gained electrons, that pi bond to it broke, and so now we have a single bond to an oxygen with an additional pair of electrons, so it has a negative charge. And then the other oxygen from carbon dioxide, nothing changed in its bonding, so it's still double bonded to that carbon. And then this carbon from carbon dioxide is that carbon right there, bonded to the two oxygens. Byproduct here is magnesium bromide. Okay, now we're almost at our carboxylic acid product. The last thing we need to do is protonate that negatively charged oxygen. So the last thing we do is add something like H3O+, so acidic water, because this is a good proton donor. That negatively charged oxygen will take a proton, and that forms our carboxylic acid product. So now we have butanoic acid. We have magnesium 2+, Br-, remember these dissociate in the presence of water, and H2O. Okay, so if we write the general reaction scheme for this reaction, we'd start with some organometallic reagent. That R group is a carbon chain, for example, propane in our mechanism that we drew above. In our first step, we add carbon dioxide. That forms that ionic compound in the second step, that intermediate with the negatively charged oxygen. And then after that is formed, we would add acidic water, H3O+, hydronium ion. And that would form our final product, which is a carboxylic acid, where that carboxylic acid carbon is bonded to the R group from the organometallic reagent.